Hello and welcome back. So I'm going to stick with inheritance today, and we're going to do a brief summary and also look at the override methods that were available to us from object. So also we're going to just talk a little bit about the thing that we had yesterday. So here we have super. We use the word super here. This is one error that can occur. If you do not use the word super, and if you just use earnings like so, it can cause infinite recursion. So it's looking at earnings and also earnings here. So if I take out super again, then it will keep thinking that it's referring to this as well. And therefore, as we learned in the data structures video, it can cause a stack overflow. So one of the reasons for the stack overflow is that you have multiple return addresses, and it's more than it can handle in the method call stack. So you definitely need super here. If a constructor has no value, this is why we need to know the default values in these things. So if a constructor has no values assigned to it, like in here, let's say for instance, if I scroll across, if it has no value, it will assign a default value. And we know already that primitive types are usually int, char, bool, these things. So we have these types, primitive types, and their default is usually 0. And then we have Boolean, which is false. And then we have reference types, which we know string is a reference type, and that's null, and that can call a null pointer exception as well. Careful with those errors. So if there's no default, it will just be assigned to null. That also goes for, in a previous example, we had a look at date, and we used date with the commission employee. And that was a reference type because it's referring to an object. So with reference types, if you think about it this way, it might be easier to remember. With reference types, there always comes methods associated to it because it's referring to an object. So now we're going to look at the default override here. So I'm going to make some room, and I'm going to click on source, and there's override implement here. Now this is what we're going to look at. So we've already overridden the code for toString. toString passes back a string representation of the object. That can use things like toString, but it actually uses the hash code, and the hash code is the int value for the object. It's a high-speed storage, and a retrieval for the information in the hash table data structure, which we'll get to in future videos. But it's another data structure that it uses. It's called a hash table. And then we also have here we have clone. Clone is not recommended. There are two types of cloning. So there's shallow and there's deep. And if you use shallow, it just takes the instance variables across, or if it's reference type, it'll just clone a reference type to the same reference type. Obviously, they have to match. Everything has to match. And types have to match. And so that's okay. It's not recommended to do, because it can refer to the same memory as well, depending on the language. So here we have as well deep cloning, and in that regard we have a new object that is instantiated as a reference type, but that's also not recommended. So we also have finalize, which we came across already. I'll post a link below to data structures and to the video on garbage collection, because finalize is used in garbage collection, and it can be we don't know when it's called, and that's a big problem with finalize. So we don't know when or how, and it's not recommended. Then there's equals. And you can see here there's brackets object. So equals, the default representation are two equals. So they're comparing two objects. Now with equals, the default is that it's comparing the two references in the same object in memory. So a lot of people think equals and two equals are the same, but they're not. So it depends on whether you want the object to be compared, as we know two equals is comparison, or not. And then there's also, well, it's not listed here, but there's also wait, notify, and notify all, and that's to do with multi-threading, which we'll get to later on as well. And there's also a get class, and that's information about the object type. And then we come to the design. So at the moment we have, let's say if I implement this, you can see what it looks like first. So object clone, throws clone not supported, and if I hover over it, the IDE tells me it's true if they're the same, if as well for equals, and for clone then it's going to be not supported in certain circumstances, so whether it's a clonable object or not. So it depends on whether it implements the clonable interface, which we'll get to soon. So we have at the moment with inheritance, it's a one-to-one based design. So inheritance based design is one-to-one. So we have a superclass and a subclass, and that's it. And the other thing is we have the access modifier, which we spoke about as well, protected, which is not recommended for use, because protected, even though we're telling the subclass to be able to access the superclass in a package of loads of different classes, they all have access now to that superclasses information. So that can be available then to access these. So if I change these private final to protected, that can cause huge problems later, because we're allowing direct access to implement changes within the data of that particular object. It's always better in software engineering design to use the get and set methods, and then that kind of prohibits and you can localize down the problem. It's called localization as well. So inheritance is specialization, and with these as well, we have another thing with the cloning is that you have different issues with using final as well. Anyway, we'll get to that as well. So inheritance is called one-to-one tight based design, and then it's usually with an is-a. So we have commission employee, and then base plus commission employee is a employee. Presumably then we have another superclass to commission employee, and then they're just one-to-one relationships. It does not support multiple inheritance. So it's better just to have it as a one-to-one, and also that's all it allows for. But then we have composition, which I think in the previous video I referred to it as collection. It's not collection, it's composition based design. And composition based design is a loose based design. It's more flexible. It uses smaller classes, a kind of a modularization of the problem. So it's easier to test, debug and modify. So if you've a larger program, then it kind of narrows it down. The other thing about that is if you're in a large organization, you might implement both because a lot of people won't agree on it. So there's no perfect design, but there'll be a mix. And that's part and parcel of a lot of software engineering, that you have a lot of people that are for, let's say, agile development processes as well as other processes, but you can pick and choose and then implement it in your own way. There's no perfect. There just is none by the book. So as we know from regular languages, when you speak it, you're not going to speak it exactly the same as you learned, let's say, French in school to a French person because they may laugh at some of the way it's said. So book software engineering versus practical are two different things as well. So the other thing then as well is the relationship between superclasses and subclasses. And the override annotation is really important. So we have 3 new keywords to remember. So we've got extends because it's like an extension of family. We have super if you want to use one of the superclasses methods. We have to remember if we're implementing this same name method within a subclass that we have to use the word super, otherwise a recursion Stack Overflow error can occur. And then the third thing is override. So when we're overriding the methods, we can go to source and you can override implement methods. In this case, I'm in the commission employee, which all objects, all classes have access to the object class because it's inheriting from every class in Java inherits from object, as we know. So when I go to base plus employee, because it extends here, I can use all of the methods within commission employee. So if I go to source and then override, it will give me a list of both and object as well. So I can easily take any of these and implement from a different way. And that's it for this video. We're going to move on to polymorphism next. So I will see you in the next video. Thanks for watching. If you liked it, give it a thumbs up and leave a comment below. I'd like to know what your feedback is. If you have any questions or anything, feel free to contact me as well. And thanks for watching.